Hello everyone and welcome back to this series of videos on the Solow growth model. Specifically lately, we've been focusing on the Cobb-Douglas production function and motivating and proving some of its assumptions. And in this video, we're going to prove mathematically and see it actually algebraically as well, the fact that the Cobb-Douglas production function exhibits diminishing marginal returns with respect to factor inputs, and we're going to focus on the marginal product of capital. What does it mean? Diminishing marginal product of factor inputs. It means that as we increase the amount of capital in our example, so as we increase it, our output is going to increase. However, how will this output increase? Well, it will increase at a diminishing rate, meaning that each extra unit of capital that will be added to the production process will increase output less than the previous unit. Mathematically speaking, it means that we need to derive the second derivative of output with respect to capital and prove that it is negative. So we are starting with our usual production function. We are assuming that technology is equal to 1 for simplicity, and we have the usual form of the Cobb-Douglas where we raise capital to the power of alpha and labor to the power of 1 minus alpha, which are respectively the capital and labor income share of output. The marginal product of capital is already derived here, and the previous video walks through the derivation of it. So now we are going to take as we said, the second derivative of output with respect to capital, or in other words, since the marginal product of capital is the first derivative itself of output with respect to capital, we are going to take the first derivative of the marginal product of capital with respect to k. So we are going to use this equation and differentiate it with respect to k. Following the chain rule, we know that we need to bring down the exponent and subtract 1 from it, so that our result here is going to look like alpha times alpha minus 1, which multiplies k to the power of alpha minus 2 and L to the power of 1 minus alpha. And we know that this doesn't change because when we measure the marginal product, we keep the other factor input constant. So in this case, we are measuring the marginal product of capital, hence we keep labor as constant. So let's look into this. We know that alpha is included between 0 and 1. What does it mean? Well, it means that this first factor here is going to be positive, and there is nothing wrong with that. However, alpha minus 1 is going to be negative. Why? Because if alpha, for example, is 0.3, if we subtract 1, we would get minus 0.7, which is a negative number. So then capital and labor are going to be positive, because if we, in case we happen to have any of these two factor inputs equal to 0, since there is a multiplication in the middle, we know that we would have 0 output. So for these actually must be positive, and they should not be negative for the sake of our argument. Hence, plus times minus is minus, minus times plus is minus, minus times plus is minus, which means that our second derivative of output with respect to capital is negative, is less than 0. Hence, it's as if we're saying that the slope of the marginal product of capital with respect to k is negative. Or in other words, that the marginal product of capital decreases as capital increases, which is exactly what diminishing marginal product of capital means. Let's look at an algebraic example, actually a mathematical example. Let's plug some numbers in to have a clearer idea of what this means. So what would happen to the marginal product of capital if capital used in the production increased by 10%? We are going to make a ratio between the old between the new marginal product of capital and the old MPK. So the new one basically includes our increase in capital that is equal to 0.1k. So we are going to write alpha, and to the capital term here, we are going to add our change in capital, everything to the power of alpha minus 1 times L1 minus alpha, again, labor constant, and then alpha k to the power of alpha minus 1 times L1 minus alpha, as this is the old MPK in the sense that there is no change. Well, so we know that this is plus 0.1, so k actually. So k plus 0.1k is going to give us 1.1k. And also we can simplify away L. Again, why is labor kept constant? It's kept constant because if we were to change labor as well, we would not be able to identify the exact increase in production thanks to capital alone. It would be kind of a confounding factor, so we have to keep it constant. And then also the alpha will simplify away. So applying the rule of indices, we know that we can rewrite everything to the power of alpha minus 1 inside a unique bracket, and that's exactly what we're going to do. So we are going to obtain 1.1k over k, everything to the power of alpha minus 1. And further, the k will simplify away so that our result would be 1.1 with alpha equal to 0.3, and 0.3 minus 1 is going to be minus 0.7. So 1.1 to the power of minus 0.7, it's as if we're writing 1 over 1.1 to the power of 0.7. And if you plug this into your calculator, you will obtain 0.935, which is, as expected, less than 1. What does this mean? So our new MPK is smaller than before, meaning that with higher level of capital, marginal product of capital is lower, which means that each extra unit of capital employed leads to less additional output than the previous unit. So to think about this intuitively, think about what would happen if we added a new machine having the same level of workers, the same amount of workers as we used to have before. So let's say that we go from having 2 machines which are working at full capacity to having 3 machines. So basically these lines here are the workers. So there are 4 workers working at each machine. Now the same number of workers have to distribute among more machines. So we still have 8 workers. So maybe 1 machine will work at full capacity, but the other 2 machines will not. They will have only 2 workers. So of course we're going to be able to produce more output because we have 1 extra machine. However, the 2 machines will not be used at their full potential, which is why the extra unit of capital, the extra output deriving from the extra unit of capital, apologies, will be lower than the change that occurred from having 1 machine with 8 workers. So from moving from 1 machine with 8 workers to 2 machines with 4 workers. Because maybe here before there was an overcrowded environment, here now we're using all of the machines at full capacity, and here we're using 2 of them, not at full capacity. So yes, there will be a positive increase in y, but the second increase in y is going to be less than the first increase in y. Thank you for watching this video, and I will see you in the following one, in the next one, where we're going to apply the same reasoning to the marginal product of labor.